Hello everyone. In this small video tutorial we will talk about how to calculate the net present value and internal rate of return using the Excel sheet. So we know that there are inbuilt programs or commands to calculate the net present value and internal rate of returns, but we will not be using it, but rather make our own worksheet. This will help you understand the concept and also will allow you to the customization if you need some answers to the problem which are not bit straightforward but require some complexity. So for example, now starts, so suppose we have a rate of return which is 10%, and we have year 1 2 year 2 3 4 and 5. So we have 5 years and we have a return cash flow of $100 in each of these 5 years. So so 1 year means that we are getting $100 after end of 1 year, right? So let me center this. So now if you want to calculate the present value of the first cash flow, so what I'll do, so I'll say present value here. So that will be equal to $100 divided by 1 plus R, where R is the rate of return. So I'll say 1 plus 10 divided by 100, right? So why did I divide it by 100? Because I want to convert the rate of return into the decimal places, and then I'll also power the 1 plus R with the number of years. So now you can see that I'm getting 90.9091. So so if I repeat it for the next cell, so you can see that again I have 100 divided by 1 plus R raised to power 2, because it is the cash flow after the 2 years. So I can drag the same cell up to the 5 years, and you can see that the value of $100 which we receive after 5 years is much lower than the value of $100 which we receive after 1 year. So if we sum all of them together, so we can say NPV, net present value, is equal to sum of all these numbers together. So this is your net present value. So as now we can check whether we did this calculation correctly or not. So let's assume that the rate of return is 0. So what will happen if the rate of return is 0? So in this case, all the $100 will remain $100. So if there is no interest on the money, then even if I get a money now or after 5 years, it's the same thing. So then the net present value should be $500. So you can see that if I put it 0, then all the future cash flows are equal to 100 and the net present value is equal to 500, right? So this is how you calculate the net present value. So now again, if the interest rate is very high, then net present value will decrease, and if it's very low, then the net present value will increase. So the more the interest rate, better is that your money is come to you earlier. If it comes late, then its value will decrease. However, if there is no interest rate, then it does not matter when the cash flow is coming. So this program is pretty much customizable. You can also put negative values here, so you can see a negative cash flow, or you can put 0 here or not put anything here. Like I can remove these things and I can calculate the net present value still. So this is how you calculate the net present value. Now let's go to IRR. So now we have to calculate the internal rate of return. So what is internal rate of return? Internal rate of return is that, suppose you invest money today and you get a cash flow in the future. So based on that cash flow, you have to estimate how much rate of return did you get on your investment. So suppose your current investment is $300 and you are getting $100 for 5 years. So now you want to calculate that how much money did you make, or how much rate of return did you get if you invested $300 now and you get $100 for next 5 years. Then how will I calculate that? So in this case, what I'll do is I'll use a goal seek command. I can do another program, but I just wanted to use this sheet here. So what we'll do is, so you can see that the net present value right now is 1, no, it's 485.343 because the rate of return is 1. So I need to bring this rate of return close enough that net present value is equal to 300, which is your initial investment. So this is initial investment, right? So now suppose I bring it, I make it 10%, so it's 379, and I make it 15%, and C35, so I make it 20%. So it's very close to the 300. But still, if we want to make it calculate the exact value of R, then we can go to something called goal seek. And when we, so to see the goal seek in your Excel, we have to go to the options and say add ins, and then click on the solver pack, solver add in, and say okay. Now again I'll go there and say options and say add ins, solver add in, and say go here, yeah, and then say analysis tool pack, solver add in, and say okay. So when I do that, then I'll get something called goal seek in the data tab. So when I click goal seek, then it will say, ask me set cell. So I'll say set cell net present value, and then to which value, I'll say to 300 because 300 is my initial investment, by changing cell R, and then I can say okay, and it will give me the value as 19.85779. so 19.8575 is our internal rate of return. Again, suppose my initial investment is $400. So how will I do it? I'll again go to what if analysis, say goal seek, and say the set value of net present value, and then to value of 400, which is our initial investment, by changing the cell R, and then I press OK. So it will say that my internal rate of return is now 7.93081%. So this is how you can program your own net present value and internal rate of return using the Excel sheet. So I hope this tutorial will help. So I'll see you next time. Hi everyone, in this small video tutorial we will talk about how to simulate a projectile motion using an Excel sheet. So let's assume that we are throwing a ball in the air at the velocity of 100 meter per second, and the angle of the throw is suppose 60 degrees, and we have a gravitational force G which will act towards the ground. So it will try to bring the ball towards the ground, and the acceleration from the gravity is 9.8 meter per second square, so second dot second. So now from here we want to calculate the trajectory of the ball in the air. So let's first assume, so we can use a numerical approach. So let's define the time. So time will be equal to 0 in the beginning, and then let's say we have a dt. So dt is the small time step at which we will calculate the point or the position of the ball. So the smaller the dt, the more accurate our calculation will be, but this is just example, so I'll just take a 0.1 second here, right? So now as you can see, the time with the time, so each time the time will increase by 0.1 second or dt, and I'm putting a dollar sign here so that it does not change the position of dt. So you can see that, so the time increases from with the interval of 0.1 second. Now let's take the velocity. So velocity in x direction. So now velocity in x direction will be equal to velocity multiplied by sine of the angle at which we have thrown the ball. So here because this is axle, so we have to convert the angle into radians first. So I'll say radians, and then I'll click on 60 degree, and I put a dollar sign here and dollar sign here. So it says that the velocity in x direction should be 86.60 meter per second, and the velocity in y direction should be equal to again velocity into the cos of radians angle and then again a dollar sign here. So that will be the velocity in the y direction. So now we can check that have we done the calculation right or not. So let's take this cell and I square the velocity in the x direction and then add it to the square of velocity in the y direction, and you can see that the answer is 100,000. And if it takes square root of this number, then that will be equal to 100, which is actually the velocity. So that means we have done it correctly, because sine square plus cos square is equal to 1. So here that's why the velocity in x direction and y direction, the square of the sum of them should be also 100. So now please enter that. So now as we know that in x direction there is no force which is acting, because it's a horizontal direction, we are ignoring the resistance due to the air. But in y direction we have a acceleration. So when we go at 0.1 after 0.1 second, there will be a acceleration which is acting opposite to the velocity of the ball. So what will happen is that the velocity will change like this. So we'll say velocity which was at time 0 plus or minus gravitational force into dt. So how did I come up with this? So again we have a velocity, and this velocity will change according to the acceleration. So you can see that there are 2 seconds in the denominator for g. So if you multiply with the dt, then we get a unit of velocity. So we are subtracting that velocity from the velocity in the y direction. However, the velocity in the x direction would remain same. So we can drag these numbers down and see that the velocity in y direction is changing, but velocity in x direction is same. And then we can calculate the distance. So at the very beginning the x will be 0 and y will also be 0, and then it will change. So the position in x direction will change according to the time. So we'll say that velocity into dt, and same way for the y. So velocity into dt. So now we can drag it down and see that the position. uh, I forgot to do one more thing. So here the x, so this is the amount or the distance which the ball has moved in the x direction, but we should add the position which was there at the initial step. So I have to say x plus the amount or the distance it has traveled in time dt. So same way here we have to add the initial position. So now if we drag it, you can see that the position will change. So this is how it will go, and we can keep dragging it for a long time. And now I can plot x versus y to look at the trajectory of the ball. So if I plot this line x versus y and say so this is what is the trajectory of the ball. And if I want to assume that I'm not standing on a mountain but I'm standing on a plain ground, so I can just end the simulation when the ball touches the ground. So for that I can just format the axis and set the minimum to be 0 and maximum, suppose let's do it. I have to see how much what is the range of the simulation, but let's do 500 here. And same way for the y, let's fix it to 2500. And now you can see that this is the trajectory of the ball. So now I can change these numbers and look at how the ball will move in XO in the air. So let's say that velocity, the angle, I change it to 45 degrees. So you can see, so now you can see that the simulation is not complete, so I should simulate it more. So here I will increase the range to suppose 1000 points. Yeah, select data, add it, and say 6 and 6. So now we can look at this again. So as you can see, when I have 45 degrees, then it goes to around 1000 or 1039. And if I change it to 55, then instead of going to 1059, it goes to 982. So as you remember, when you learn the trajectory of a ball, the ball goes to the maximum distance when the angle you throw at is 45 degree. So now you can see that when I was throwing at 45 degree, it was going to 1050, but when I throw at 55, it goes to around 950. And again, if I throw at 35, then again it goes to around 975. So the maximum distance you will cover will be when you throw it at 45. So this confirms that our simulations are correct. So now you can play around with it, saying instead of 35, if I throw it at 20 degrees, then it goes pretty much up. And if I throw it at 80 degrees, then it doesn't go up, but mostly towards the ground. It doesn't take a lot of height. So I hope this tutorial will help, and I'll see you next time. Hi everyone, in this tutorial we will talk about the problem of annuities. So there are many times that what happen is that we are getting a constant cash flow for every month or maybe every year, and we want to see how much does it cost now, or what is the value of that annuities now. So for example, suppose we have a cash flow of $100 every year. So this is the end of 1 year, 2 year, and we are getting $100. So I'll say $100 and I keep dragging it, and let's say it is for 20 years. So we are getting $100 every end of every year for next 20 years, and we want to calculate what is the value of this amount today. So what will I do is I'll say that suppose the rate of return or rate of interest is 0.1, which is 10%. So here, so what I'll do is I'll calculate the present value of each dollar amount. So this was the cash flow, and then we have a present value. So present value will be equal to 100 divided by 1 plus R. So I'll put a dollar sign here so that if I drag this cell down, then it will not change the R. And then I take the power with the year of the payment. So because for the first year it will be 1, and then for the second year it will change according. So as you can see that the values are changing, so we can drag it down and see that the $100 we'll receive after 20 years will only be equivalent to $14 we received today, right? And then we can calculate the total value. So we can say net present value is equal to sum of all these values. So this is our again is equal to sum of all these values. So as you can see, so this is the net present value. So when we change the interest rate, like suppose from 0.1% to 0%, then you can see that the net present value is equal to 2000, which is that's the value of $100 even after 20 years is equal to $100. So that's why the total sum is equal to 20 hundreds. So but when we have an interest rate, then it goes down, right? So now we can further go about it and so make it something else. So suppose now that we want to give money to someone and he wants to pay you back in the installment. So how much installment should you charge him? So suppose you are giving someone 0.1 is the interest rate, so which is 10% interest rate, and somebody borrows $100 from you. So let's say money borrowed, right? So that is equal to 1000, or let's say $1000. Somebody borrows 1000 from you. So how much payment he should make you every year for next 20 years? So how will we go about it? So what I'll do in this case is that I'll go to the data tab and click on the goal seek. So I'll say data tab, what if analysis, and goal seek. So it says set cell, so I'll say set cell net present value and then to value, because the money borrowed is 1000, and then I'll say by changing cell, so I'll say cash flow and say okay. So you can see that now the net present value is equal to the money which was borrowed, and then the cash flow should be 117.46. So the person should pay you 117.46. and now let's assume, let me bring this let me bring insert here. And now suppose the person wants more detail on the payment he's making. So he wants to know that whenever he make a payment, how much he is paying for interest and how much he is paying for the principal. So how can we calculate it? So what we can do is that at the end of 1 year he will be paying the interest on $1000, right? and the interest rate is 1% or 10%. So we'll calculate the interest as is equal to principal into the interest rate. So that is your $100, but he's making a payment of 117. So principal paid will be equal to cash flow minus the interest payment. So that is equal to $17.45. So he only paid a principal of $17.4596. So what will happen next year? So next year the principal left will be equal to money borrowed minus principal paid, right? And I'm putting a dollar sign on the so let's do it this way. So now this is the principal left. So next year what will happen? I'm again paying the interest, but this time the interest will be on the principal left, right? So I'll say principal left into the interest rate, and the interest rate, for interest rate I'll put a dollar sign so that when I drag this cell down then it does not change. And you can see now this time the interest will be lower because the principal is lower, and then the principal paid will be higher because the interest which is paying is lower. And now, so what will the principal left? Principal left will be equal to principal left last time minus the more principal which was paid. So that will be equal to 963 now. So now we can keep dragging this down and see how does it changes. So you can see that we get the money flow. So you can see that the interest which has been paid is going down, the principal left is also going down, and the principal paid every time is also going up. So we can see that the end of 20 years he will be paying $10 as interest and 106 as the principal. So the interest amount is very low and it will leave him with a zero balance. So here it is giving 1.7 to 10 to the minus 13, which is 0, but because it's Excel, so it calculates to the way long decimal point, so it should be 0. So this is how you calculate. So you can do this calculation easily in the Excel sheet and give it to the borrower, or even if you borrow money from someone, you can do the calculation and see how does the cash flow will look like, or how does your payment works when you make a loan, or you pay a loan. So I hope this tutorial will help. I'll see you later. Thanks. Hi everyone, in this small video tutorial we will talk about some of the basic calculation we need to do in our chemistry lab. So it's very handy for the students in first year or in freshman years. So for example, if we have three components x, y and z, and we want to mix them in a molar ratio of 1:1:1, and their molecular weight is given to us, suppose it's 100 for 300 and 50, and we have a molecular weight, we have a molar fraction of 1, 1 and 1, and we want to mix them together and create a total and we need total of 10 grams. So how much of the each of this substance we should mix to get the molar ratio of 1:1:1. So how to approach this problem using the Excel? So these are some of the basic things which a student has to deal during his homeworks or in the lab. So we'll show you how to calculate this. So now so as we know that the total moles is 1:1:1, so it's 3 moles. So what I'll do is I'll say mol 1 plus mol 2 plus mol 3. So this is the total number of moles, and then we'll say no mole of number first x, and then we divide it by the total number. So this is, I divide the mole of the x which are required divided by the total number of the moles which is required. So this will give me the percent mole of the x, and then I multiply this by its molecular weight. So so you can see, so now I need to put the dollar sign here because these terms remain constant. So this is R33.333, and if I do the same thing, so you can see that if we add this weights together, then we should get a molar ratio of 1:1:1, but we need a total of 10 grams. So what we'll do is again we will take the sum of all these three together, this plus this plus this, and then we multiply it by this. So now it gives us the weight percent, and then we multiply it by the 10 here. Dollar, dollar, and dollar, and then also a dollar for this one. So now you can see that if I add them together, so this is the answer. So you can see that if I sum them together is equal to sum, so the total sum is 10 grams. So we should add this many grams of these three components to get a molar ratio of 1:1:1. So now if we have, so we should check whether we did the calculation correctly or not. So as we know this is in grams, so we can calculate the moles. So while we calculate the moles, we can divide the grams by the molecular weight. So this is our moles. So if we do this together, so you can see this is the mole. So you can see the number of mole of all the three components is exactly the same. So this is because we were taking the molar ratio 1:1:1. If I put a 2 here now, so we don't have to do the calculations again. We can just use this Excel sheet again and again. You can put 2 here, and you can see that the number of moles doubles, and the grams also changes here automatically, but the total number of grams remains 10. So this is how we calculate the amount of moles, or amount of the substance we need to add together to get a desired molar ratio. So I hope this tutorial will help, but this was just a quick way. You can also find the better ways to do this calculation, but I went to the longer route so that you can understand the concept. Otherwise we can go to much shorter ways if you think more about it. So I hope this tutorial will help, and I'll see you again next time. Hi everyone, in this tutorial I will show you how to solve set of differential equation using an Excel sheet. So I will be using an analytical approach to solve these differential equations. For this particular video tutorial, I have used the example of diffusion. Here I have defined two chambers, inside chamber and outside chamber. So there is a concentration of C in the inside chamber and C out in the outside chamber. The outside chamber is exposed to air, so the things in the outside chamber can diffuse to open air with the diffusion coefficient of K dash, and from diffusion can occur from inside to outside with the diffusion coefficient of K double dash. And these are the differential equations. These are pretty standard differential equation for diffusion, where change in the concentration is proportional to the concentration difference from where the diffusion is occurring. And to solve this differential equation analytically, we need to go to a very small time scale, and if we go to very small time scale of dt, then we can rewrite this differential equation again in this form. So here, instead of writing dt, I'm writing C in at t is equal to t minus C in at t is equal to t minus dt. So here I'm saying that if I assume a very small time scales, for example 1 millisecond or 10 millisecond, then I can just assume that DC is just a subtraction of C at a forward time minus C at present time. And similarly, instead of writing C in, I can say that C in is something at the backward time. So I can write these equations like this. Now to solve this equation, I need to define k double dash. So let's call k double dash is equal to 1 and k dash is equal to 2. So these are the arbitrary numbers. You can change it later if you like. And then let's define dt, and dt is equal to 0.01 here. So let me write 0.01. Now what I'll do is I'll first define t. So t, so I'll say t, and t is equal to 0 in the beginning. So at t is 0, t is 0. So let me, and then let's define c in and then c out. So let me center them. Yes. So now C in, let's assume the initial concentration is 100 in the first chamber and 100 in the outside chamber. And now at after time dt, the time will be dt. So that what we call is that t plus dt. And because dt is constant, so I need to put $sign with this number. So that will ensure that dt is not changing if I try to grab this series down. Now C in, so for C in I will use the formula which is defined here. Let me grab the differential equation here. So I'll say C in is equal to C in at t is equal to t minus dt minus dt. So this is dt, and I put $sign again, and then into k dash double dash. So k double dash again, I put a $sign here, and then into c in minus c out. And now here I'm not putting a $sign on C in and C out because the C in and C out are not constant and they will change with the time. So I'll put enter here. And now here C out, let me grab the equations here. And I say C out is equal to C out at t minus dt, and then minus dt which is constant, so I put $sign here, and then into k dash is constant, so I put $sign here, and then into C out. So C out is not constant, so it will be C out here. I'll press enter. So now this is what I have. Now all I need to do is grab these three numbers and then drag them down. So I need to simulate for long time because I want to go to t infinity and see how does it go. So let's stop here, and you can see the concentration in both the columns are now approximately or very close to 0. So now if I go up, I can plot, and then this is a plot for C in and C out. But as you can see, this two curves goes to 0 because if you look in our model, the diffusion is happening from chamber to the open air, and open air is a sink, so everything will eventually evaporate and goes to air, so everything will be consumed. So concentration should go to 0. That means our model is working. However, we can see that we can vary the speed here by changing the diffusion coefficient. For example, now we have k double dash is equal to 1, so if I put k double dash is equal to 5, then the speed is much faster. And now if I put it slower like 0.5, then speed is slower. Like a dynamic model, so where I can change the numbers and I can see the results right away. And this is a simulation. So differential equation, I don't need to use the algebra or calculus to solve this. I'm just using a simple method to solve the differential equations and come up with the pattern, and with the parameters I can change the patterns here.
Hi everyone, in this video I will talk about how we can calculate the probability of a stock to go up or down for the next coming day. So here we will use the historical data on that stock, and from that we can predict the future price. So here let's go to Yahoo Finance, and I'm looking at the stock of Apple. So if on the left column I can click on historical prices, and then I can see that it give me the price of every day since 1984 in this sheet. So I don't need this much of the price detail. So let's take the value for last 5 years approximately. So I'm instead of here 1984, I'm putting 2000. No, this is 1007, and now I say get price. So now it give me a new price uh, details, and then I can go down and say download to spreadsheet. So this give me all these numbers like this. I can select these numbers, copy them, and then paste them in an Excel sheet. Now this values right now are copied as text, so we need to convert them to the data. So if we go to data and say text to column, and then I'll say delimited and select comma, because this data is comma separated, and then say finish. So now I have all these columns with different values for open price, high price, low price, close price. So now I'll get rid of all these columns and just left with the close price. And now what I can do is I can calculate what was the percentage change in the stock value every day. So for that I will divide the present value with the value from the last day, and that will give me so 0.966. So the value of the stock remained 96.6% after uh, on November 2nd as compared to November 1st. So I can calculate the percentage by doing subtracting 1 from this number and then multiplying by 100. So that suggests that there was 3.3% decrease in price of Apple on November 2nd. And I can do same thing for all the historical prices and click double click here, and it copied, and you can see that the price change was different on all these different dates. Now let's do the counting how many data points we have. So I say 1 2 and then select and then click like this, and now let's take only the first 1000 data points. So I'll go down and see that whenever my 1000 data points are complete, I'll get rid of all the other data points. So now I have total 1000 data points. So what I'll do again is I'll divide this number in column H by 1000, and then I'll copy again, and I get this 0.001, 0.002, 0.003 like this. And then I copy this percentage change column and then paste it in a special way, because I don't want the formula, I just want the values. I'll say paste only values here, and I got this values. And now I select this column until here and say sort. So it sorts the data. So you can see that the maximum change in the stock price in last around 5 years was 6.7% decrease, and same way the increase side, it was 12.55% increase. And so right now I have not sorted it according to the date, so I don't know which date it was, because I'm not concerned about the date. I'm just concerned about the movement of the stock during the past 5 years. Now what I can do is, now this is my percentage change, and this is my cumulative distribution function, or the probability. So I can plot these two. Let me move this here, and now I can plot these two functions to these two columns and get this cumulative distribution function for stock of Apple. This curve could be difficult, so I can also do or write a function here. So I can use lookup command. So I'll say, let's assume that we want to calculate the probability of point 0.5. So I'll say lookup and then I select this value, because I want to look up 0.5, and then I'll select this column, and then this is my result column. So my result column will be we'll put it like 0.7 here right now. So there is a 70%. So you can see that there is a 30% chance, because 1 minus 0.7 is 3.3. So there is a 30% chance that the stock will return a gain of more than 0.9697%, or about 1%. So it can return more than 1% on a coming day, based on this historical data. So if I put it zero point 0.8, so I can say that there is a 20% chance that the stock will return 1.5 more than 1.53% in the coming days. So now I have just rearranged these numbers, and if I say 20 here, then the percentage chances probability that stock will gain more than 1.53% on the next day. And if I say 10%, then there is a probability that it will gain 2.523%. So the chances are only 10%. So this can be a handy way to calculate the probability of the stock gaining a particular price in a coming day.